Python, Inflate and Deflate implementations. I am interfacing with a server that requires that data sent to it is compressed with deflate algorithm, Huffman encoding plus LZ77, and also sends data that I need to inflate. I know that Python includes lib, and that the C libraries in lib support calls to inflate and deflate, but these apparently are not provided by the Python's lib module. It does provide compress and decompress, but when I make a call such as the following, I receive the following error. Zip does no better when making a call such as I receive the error, which makes sense as the data is a deflated file, not a true zip file. Now I know that there is a deflate implementation available, Pyflate, but I do not know of an inflate implementation. It seems that there are a few options. Find an existing implementation, ideal, of inflate and deflate in Python. Write my own Python extension to this libc library that includes inflate and deflate. Call something else that can be executed from the command line, such as a Ruby script, since inflate/deflate calls in lib are fully wrapped in Ruby. I am seeking a solution, but lacking a solution I will be thankful for insights, constructive opinions, and ideas. Additional information. The result of deflating and encoding a string should, for the purposes I need, give the same result as the following snippet of C# code, where the input parameter is an array of UTF bytes corresponding to the data to compress. Running this .NET code for the string deflate and encode me gives the result. When deflate and encode me is run through the Python's lib.compress and then base64 encoded, the result is Schlsu 3 Fusions 1 fizz, UVIT 0L, V0 FAF 6K equals. It is clear that zlib.compress is not an implementation of the same algorithm as the standard deflate algorithm. More information. The first 2 bytes of the .NET deflate data, 7B0 high, after B64 decoding are 0Z, which does not correspond to zip data, 0x1F8B, zip2, 0x425A data, or zlib, 0x789C data. The first 2 bytes of the Python compressed data, EJXLS, after B64 decoding are 0x789C. This is a zlib header. Solved. To handle the raw deflate and inflate, without header and checksum, the following things needed to happen. On deflate/compress, strip the first 2 bytes, header, and the last 4 bytes, checksum. On inflate/decompress, there is a second argument for window size. If this value is negative, it suppresses headers. Here are my methods currently, including the base64 encoding/decoding, and working properly.
This is an add-on to Mizard's answer, giving some explanation and background. See this URL. According to RFC 1950, a zlib stream constructed in the default manner is composed of a 2-byte header, for example 0x780x9C. A deflate stream, see RFC 1951. An ADLER32 checksum of the uncompressed data, 4 bytes. The C# deflate stream works on, you guessed it, a deflate stream. Mizard's code is telling the zlib module that the data is a raw deflate stream. Observations: 1. One hopes the C# deflation method producing a longer string happens only with short input. 2. Using the raw deflate stream without the Adler32 checksum. Bit risky, unless replaced with something better. Updates. Error message: block length does not match with its complement. If you are trying to inflate some compressed data with the C# deflate stream and you get that message, then it is quite possible that you are giving it a zlib stream, not a deflate stream. See how do you use a deflate stream on part of a file. Also copy/paste the error message into a Google search and you will get numerous hits, including the one up the front of this answer, saying much the same thing. The Java deflator, used by the website, C# deflate stream is pretty straightforward and has been tested against the Java implementation. Which of the following possible Java deflator constructors is the website using? Public deflator int level, boolean no wrap. Creates a new compressor using the specified compression level. If no wrap is true, then the zlib header and checksum fields will not be used in order to support the compression format used in both glip and clip. Public deflator int level. Creates a new compressor using the specified compression level. Compressed data will be generated in zlib format. Public deflator. Creates a new compressor with the default compression level. Compressed data will be generated in zlib format. A one-line deflator after throwing away the 2-byte zlib header and the 4-byte checksum. Or
you can still use the zlib module to inflate/deflate data. The xzip module uses it internally, but adds a file header to make it into a xzip file. Looking at the xzip.py file, something like this could work. I don't know if this corresponds exactly to whatever your server requires, but those two functions are able to round-trip any data I tried. The parameters maps directly to what is passed to the zlib library functions. Python C. zlib.compressor ... deflate init ... compressor.compress ... deflate ... zlib.decompressor ... inflate init ... decompressor ... decompress ... inflate ... The constructors create the structure and populate it with default values and pass it along to the init functions. The compress/decompress methods update the structure and pass it to inflate/deflate.
If you want to see more, please consider subscribing.